Okay, let's take a look at today's lesson. We're going to look at graphs of f, f prime, and f double prime. Basically, we're going to find information off of graphs and apply it to questions. That's what we're going to be doing, looking at it graphically. So this is the exact kind of question that you might see on the AP test. Notice we have our little graph right here, and we have a prompt. So let's go ahead and start. Alright, so we have the graph of y equals f prime is given, and the domain is -3 to 3. So we have to note this is f prime, just to make sure we know what we're looking at. Let's see, and then they gave us some function values. Right now we're really not sure what to do with these, so I would just box them so I remember that they're there and then go back to them when I need them. I don't know what they're for yet, but I'm sure we will find out. Then what I would do is kind of step back and look at the kinds of questions that were being asked. Let's see, increasing, concavity, maximums, inflection points. So what we like to do with those kinds is we need a sign chart, right? That's how we usually answer those questions, with a sign chart. So why don't we turn this graph into a sign chart? Let's just turn our first derivative graph into a sign chart. So let's think. So what kind of numbers do we have on the sign chart? Well, we have the numbers where the first derivative is 0, right? That's what we put on the critical numbers. So let's look and see which, let's see, I have a 0 right here, so I would have this number on my sign chart. I would have 0 on my sign chart, and I would have 2 on my sign chart. I'm just going to kind of mark it off like that. I'm making a sign chart for f prime. The reason I'm doing this is so I don't have to constantly analyze the graph over and over again. I'm going to analyze it one time, write down my sign chart, and then not worry about the graph again. All right, so what do we have going on here? Let's see. So from -3 to -2, the y values of f prime are positive, so that means that this would be a positive section. From -2 to 0, the y values of f prime are negative, so that means that this would be a negative section. Because that's what we'd be doing, right? We'd take the derivative, we would find a point in here, plug it in, see what value we got. This is all about y values. So between 0 and 2, this section is positive, and that section is positive. All right, so there's our sign chart for f prime. But it is also asking us about concavity. And which derivative do we get concavity off of? It's the second derivative, right? I really need a chart for the second derivative. So I'm going to make one, but how do we read the second derivative off of a graph of the first derivative? It's the slopes, right? We've done this before. We've basically done this before. So this is kind of a review lesson. There's a lot of review. There's really only one kind of new thing today, and that's this part E. But that's what we're going to do. So f double prime, I'm going to make another sign chart. Let's see. So we look at the slopes. So I've got to figure out what numbers would I put on my f double prime sign chart. I would put the numbers where my slope is changing, right? That's what I would do, because that's this picture of f prime. The slopes of f prime are the y values of f double prime. Okay, so here I have a slope of 0. So I'm going from a negative slope to a positive slope. So -1 would be on my f double prime chart. Let's see where else it would happen. We would change slopes here at 1 and again at 2. So my the double prime chart would have 3 numbers on it. All right, so now let's see what signs we would make. So this slope right here, those are all negative, right? So that would be negative. Here, that's positive slope, so that would be positive. I've got some negative slopes here, so negative, and positive slopes, positive. Okay, great. So now I have my sign chart for f prime and f double prime, and I don't really even need to reference the graph any longer. Are we okay with that? Now we're basically back to analyzing sign charts, because we know how to do that. We're pretty good at that. So let's do that. So part A says, for what values of x is the graph of f increasing? Okay, so let's think here. So increasing, that means that the first derivative is positive, right? That's increasing. We've done that test before. All right, so the first derivative is positive between -3 and -2 and 0 and 2 and 2 to 3 because f prime is greater than 0. Regular old justification like we normally do. Okay, let's look at B. For what values of x does the graph of f have a relative maximum? Okay, that goes back to our first derivative test. First derivative test, maximum is where we go from increasing to decreasing, right? Increasing to decreasing. That happens at -2. So x equals -2 is a relative maximum because f prime changes from positive to negative. Okay? So that's why we have a relative maximum there with our justification. Should all be reviewed, right? It's pretty comfortable. We should be fine. Okay, so C, for what values of x is the graph of f concave up? All right. So we need to be concave up. Concave up, where do we read that information off of? Off the second derivative, right? So I need to look at the second derivative. So we're going to focus our attention up here on this part. So we want to be concave up. So the second derivative would be what sign when we're concave up? It'll be positive, right? So I'm going to look for the positive sections of the second derivative. All right, let's see. So that's between -1 and 1 and 2 to 3. Now I'm going to go ahead and put our endpoints here because that's our domain. We really can't, look outside of there. So basically that's like that area we can't consider because it's not in the domain. All right, because f double prime is greater than 0. Okay? Part D says, for what values of x does the graph of f have an inflection point? Okay, so let's think back. Inflection points, where do we find that from? That is second derivative, right? And inflection points are where we change concavity, right? So the inflection points would happen when the second derivative changes signs. So let's look and see where it changes signs. All right, so it changes signs at -1, at 1, and at 2. Wow, 3 different inflection points because f double prime changes signs. Okay, so here I just wrote it changes signs. Is that okay? That's okay, right? Would it have been okay on part B if it says it was a relative maximum because it changes signs? Would that be okay? No. The test says specifically it has to change from positive to negative, right? From increase to decrease. You can't just leave that off. Now I'm leaving it off on part D because it doesn't really matter which way it goes, right? It's still an inflection point. Whether it goes from concave up to concave down or concave down to concave up doesn't really matter. So I want to make sure we are clear about that. Part E is really the kind of the new part that we're going over today, and it's really probably the hardest part on here. So what I'm going to actually do is I'm going to skip to part F, and we're going to graph it first. Then I think part E will make more sense. Once we see the graph, I think it'll make more sense. Part E is asking us to find the values of x for which we have an absolute minimum. Absolute, not relative, but absolute. So that's a different kind of thing, right? So let's go ahead and graph it first. Let's skip to part F. It wants us to use the information found to sketch a possible graph of f. So the first thing, I'm just going to take you through steps, on graphing. These are the same steps I do every single time. And if you are a person that likes to write down steps, you should probably write them down. So step 1, I plot any function values that I have. Those are non-negotiable. The ones up here in the box, these are non-negotiable. They have to be on the graph. So that is the very first thing that I do is I plot those points. So let's do that. So -3, -2. Let's see, so -3, -2 is right here. Then we have 0, 1 right here. Let's see, and then 3, 3. 3, 3 is right here. Okay, so it's the very first thing that I do, non-negotiable, right? Those have to be there. The second thing that I always do is I look for extrema, mins and maxes, relative mins and maxes. That's the second thing that I do, because those we need to kind of lock in. So let's look at our first derivative sign chart, and let's determine what kind of extrema we have. Let's see, at -2 we have a maximum. Unfortunately, I don't have a function value there already, but since it's a relative maximum, I'm just going to kind of go, maybe up here somewhere, and I'm just going to put like that shows me I have a relative maximum there. Now, if I put that in the wrong place, I can always change it, but that shows me I have a relative maximum at -2. Okay, so now let's see what other, let's see, at 0, I have a relative minimum. Now at 0, I do have a value that's I have to use. So I'm going to put like this little thing here to show that I have a little minimum there. And that's the second thing I always do, is deal with the relative extrema. The third thing that I always do is I'm going to draw the actual curve. And when I draw the actual curve, I have to really look at two things at the same time. I have to look at increase, decrease, and concavity at the same time as I'm going through. So I always, typically, not always, but mostly I start from left and go right. That's what I normally do. So let's do that. So start at the left. Let's see, we are increasing from -3 to -2, and we are concave down. Okay, so that's not bad. I can just do that. Okay, that's fine. Increasing, concave down, that works. Now let's investigate what's happening between -2 and 0. Let's see. I'm decreasing all the way from -2 to 0. So I'm going to decrease, but let's look and see what happens to concavity. I'm concave down, and then I turn concave up at -1. So I'm concave down, and then I turn concave up at -1. And so since we're drawing these by hand, I need you to make it exaggerated so that I can see what you're doing. It just helps me grade it better, right? And it's a sketch. We're just going to exaggerate the concavity. Would it be exaggerated this much in your calculator? Probably not. But for me to be able to determine that you're changing concavity, I need to see it. I need to be able to see that you're changing concavity. All right, so we're good from -3 to 0. Are we all okay there? Okay, from 0 to 3, I think is a little bit more challenging. We're increasing that whole time from 0 to 3. It would be nice if I could just draw a line and be done, but the concavity is crazy over there. It's crazy. It goes from, let's see, from 0 to 1, we're concave up. From 1 to 2, we're concave down, and from 2 to 3, we're concave up. Okay, so let's try to make that work. So from 0 to 1, we're concave up. So we'll just continue like we are right here. Then from 1 to 2, we're concave down. So we're just going to make it concave down. And then from 2 to 3, we're concave up. Okay, so my concavity is exaggerated so that you can see the change in concavity. If you're worried on a quiz or a test that I won't be able to tell what you're doing, you're always welcome to label it and, say, just point and say concave up, concave down, or you could even point out where the inflection points are and concave up and concave down. It's just, if you're worried about it, you can give me extra information so that I'm sure to catch what you are graphing. Now that we look at this graph of this function, part E is a little more understandable. We can look at that and see, yeah, we have an absolute minimum. We have an absolute minimum at x equals -3. We can see it's right there. All right, so the first thing that I want you to do is state the fact. All right, at x equals -3, there's an absolute minimum, the absolute minimum value, and we know it. Sometimes we don't know the absolute minimum value. We do now. The absolute minimum value is -2. Okay, that's stating the fact. We should all be able to state the fact. Now, the explanation, the justification is a little bit more complicated because it's actually an explanation or justification using your logic. It's not like this where we can say because f double prime is greater than 0. It's a bit more complicated than that. We have to use logic to explain. And what I'm going to do is I'm going to write down the logic that I used. So let's first of all think the logic through. So we started here because that was our function value, and we increased till we got to -2, right? Then we decreased. The only chance to get back down here is to decrease enough to get back down here, right? I would need a decrease lower than -2. But I only decreased to 1, and then I started increasing again. So you see, logically, this has to be the absolute minimum. Because in my decrease path, I didn't go down there, right? I stopped here. And you're saying, well, what if I went down and came back up? Well, we can't, right? Because it's clearly the only time that we decrease is in this area. I mean, that's the only time we decrease. That's the only chance we have of getting below -2 is between this interval right here. And this interval, I have to continue to decrease all the time. I have to continue to decrease, and I stop decreasing when y is 1. Okay, are you with me on the logic of why that has to be absolute minimum? Writing it out may be a little bit trickier, but I'm just going to write down what I put. So this is the only location. This is the only location the absolute minimum exists. Because from -3 to -2, f of x is increasing, comma, then from -2 to 0, f of x is decreasing. But the function value at x equals 0 is only 1. It doesn't get lower than 1, or is 1. You don't say only, is 1. So I had a question earlier today. Well, can't we say that f of -3, that at -2 is the lowest value in the graph? Okay, you can say that, but does that say why? Have you provided a reason why, or did you just state the fact again? So that's the danger here. We don't want to state the fact again. We want to say why. Why is that true? Okay? We okay with that?